everyone! Today, we'll be talking about ellipse in real life. In this video, you'll see an object that represents an ellipse. And through this, we will show that ellipses are actually present almost everywhere around us, even in simple everyday items that we might not really notice. So, what is an ellipse? An ellipse is a closed geometrical curve that resembles a stretched circle. It is defined as a set of all points in a plane where the sum of the distances from two fixed points, called the foci, is constant. It has a major axis, the longest diameter, a minor axis, the shortest diameter, and a center located at the midpoint of both axes. Now that we understand what an ellipse is, let's move on to our introduction of scenario. A laundry basket have a top opening shaped like an ellipse, where the major axis represents the longest measurement across the basket, and the minor axis represents the shortest measurement from front to back. This elliptical top shape allows the basket to hold more clothes while remaining space efficient and easy to carry or store. And now for our problem statement. Suppose a designer is creating an elliptical laundry basket. The length of the basket from one end to the other, the major axis, is 60 centimeters, and the width across the shorter side, the minor axis, is 40 centimeters. For our equation of the ellipse, in this example, we are using a laundry basket to represent an ellipse because the basket is longer from side to side than from front to back. The major axis is horizontal. That means the width of the basket is a longer measurement and the height is the shorter one. We place the center of the ellipse at the point 0, 0 to make it easier to grab and work with. The major axis length is measured to be 60 centimeters, so half of that is 30 centimeters. This gives us the value of A is equal to 30. The minor axis length is 40 centimeters, so half of that is 20 centimeters, giving us B is equal to 20. So as you can see, our center is at 0, 0. Our major axis is horizontal. Our major axis length is 60 centimeters. Our minor axis length is 40 centimeters, and the value of RA is 30, and the value of RB is 20. When we write the equation of an ellipse with a horizontal major axis, we use the form x squared over a squared minus y squared over b squared equals to 1. So we substitute the values we found. So x squared over 30 squared minus y squared over 20 squared equals to 1 is going to be x squared over 900 minus y squared over 400 is equals to 1. So that gives us the final equation. Now that we have the equation of the ellipse, we can identify the vertices and co-vertices. These points help us see the actual size and direction of the ellipse on the graph. So the value of RA is equal to 30, RB is equal to 20. Since the major axis is horizontal, the vertices will be located to the left and right of the center. We use the value of A is equal to 30, so the vertices are 30 and 0 and negative 30 and 0. This point represents the widest part of the ellipse, the longest stretch of the basket. Next, the co-vertices lie along the minor axis, which is vertical. We use the value of B is equal to 20, so the co-vertices are 0 and 20 and 0 and negative 20. These points show the height of the ellipse, the shorter dimension of the basket. Next, we find the foci of the ellipse. The foci are two fixed points found inside the ellipse. They help define the shape because in any ellipse, the total distance from any point on the curve to both foci is always the same. Since our ellipse has a horizontal major axis, the foci will be located left and right of the center, just like the vertices, but closer to the center. To find how far each focus is from the center, we use the formula C is equals to square root of A squared minus B squared. We already know RA is equals to 30 and RB is equals to 20, so it's going to be C is equals to square root of 30 squared minus 20 squared. And then we substitute, so it's going to be C is equals to square root of 900 minus 400. And then C is equals to the square root of 500. And then we're going to get the square root of the 500, so it's going to be C is equals to 22.36. This means each focus is 22.36 units from the center along the x-axis. So the coordinates of the foci are 22.36 and 0 and negative 22.36 and 0. These points lie inside the ellipse and they show how the shape stretches horizontally. So for our graphing, first we look at the center, which is at 0, 0. So we will plot the center right where the x-axis and y-axis meet. This point will be the middle of our ellipse. Next, we move to the vertices. The vertices are 30 and 0 and negative 30 and 0. Since our graph is counted by tens, we will count 10, 20 till 30 to the right. So there. And the same steps to the left. So we have 30 and 0 and negative 30 and 0. Now we look at the co-vertices, which are 0 and 20 and 0 and negative 20. This time, we count up and down from the center. We count up till 20, so it's going to be here, and down till 20, so it's going to be here, and that gives us 0 and positive 20 and 0 and negative 20. After that, we identify the foci, which are 22.36 and 0 and negative 22.36 and 0. This value is a little more than 20, so we place the points just past the 20 mark on both the right and left sides of the center. So we plot the foci slightly beyond 20 and 0 and negative 20 and 0. So it's going to be here and here. Finally, after plotting the center, vertices, co-vertices, and foci, we sketch a smooth curve that passes through the vertices and co-vertices. This gives us the complete shape of the ellipse. For our real-world interpretation, the major axis, 60 centimeters, represents the longest distance across the laundry basket, giving it enough space to hold larger clothing items like towels and jackets. The minor axis, 40 centimeters, represents the shorter width of the basket, helping it stay easy to carry and fit in smaller spaces such as laundry rooms or corners. The foci positive negative 22.36 centimeters from the center are points inside the ellipse that determine how the basket's shape stretches. Their placement ensures that the basket has a smooth, rounded form rather than a perfect circle. This makes the basket look more natural and provides more volume without taking up extra space. In real life, this elliptical shape helps the basket balance capacity and convenience. It holds more clothes while still being comfortable to carry and store. And that's how we can see an ellipse in real life. This example shows that math isn't just in books, it's all around us. Thank you for watching!